There were no graphics on the early internet connections, just text like this. In this project, we're going to extend the internet in the same way as those early pioneers with nothing but text, to see how it was done. It would be good to use some of the computers employed in the 1970s, but they were large, expensive and slow, and we probably couldn't afford the electricity to run them. So we're going to use a number of smaller, faster, cheaper machines. No, smaller, still too big. No, something the size of a credit card. Yes, that'll do, the Raspberry Pi. We can start extending the internet with, say, 4 Raspberry Pis. This is how it's done. The first thing to do is look at the Pi and see what connections it has. The juice, the power, goes in here. It's easy to recognise because although it's small, it's the same type of power connector as used on mobile phones. The HDMI video is connected here, and this drives a good quality graphics monitor. These 3 blocks look similar, but these 2 are the same. They are USB connectors, and the keyboard can be plugged into any one of the 4 available sockets. The other metal block is for our network connector, and this is the one that is going to carry out internet data. As we don't have 4 wall sockets free, we're going to connect all of our Pis to this hub, and then connect the hub to the single wall socket. The hub just helps us share the single wall socket, little else. Note that this hub has 24 ports, so we could connect even more devices later. We can now turn everything on and see what happens. If all has gone well, all 4 of our machines should have gone through their boot process and arrived at a screen displaying a prompt like this, just tempting us to enter something. One of the great things about the Pi is it understands and follows the same commands as those on the original internet, as well as most of the very biggest machines in the world today. Here it's called Linux. No Windows here, as we're doing real computing, not playing with toys. At this stage, you have to ask yourself, do I want total power? Do I want to be number 1?
Become indomitable?
If your answer is no, then go off and search the internet for kittens. If yes, proceed. In the Linux world, the user with ultimate power at the top of the tree is called root. Enter root and root password. Once the process has been cleared, you have total control of the system. Logging in directly as root may not seem to be much of a deal, but there are some Linux Taliban who regard this as bad practice, as it involves risks. But hey ho, life is nothing without risks. Well, at least I've warned you about what they said, so back to the power. The first command to issue is interface configuration. This reduces to ifconfig and produces this. This is typical of Linux. Lots of confusing, unfriendly, technical gobbledygook and not silly pictures. But do stick with it. The response on each of the 4 machines must be different here. This number, following the word inet, as this is the machine's inet or internet address, and like your home address, is useless unless it's unique. It's known as the IP or Internet Protocol address and consists of 4 numbers that can vary between 0 and 255, separated by 3 dots. Without this address, your device can't connect to the internet, as nobody knows where to deliver your data. Pause this video now if you want to see how this number comes about. Now, you've no doubt seen films where a warship uses sonar to flush out a submarine lurking below the waves. Well, Linux uses a similar system called ping. This provides a useful tool and the most basic way of proving you have a connection with a device on another address. Ping 192.168.0.1. The pings go out in sequence, and this column shows the time taken to respond. MS stands for milliseconds, which are 1,000th of a second, so you can see this response is quite quick. Logging in and discovering the IP address for all 4 Pis means that we can see how quickly the pings take to reflect between each machine. So our local network is working. The first big test. Now IP addresses may be new to you, but you've been using them without knowing all the time. When you've browsed the BBC on the internet, you've used the more friendly web address of www.bbc.co.uk. You can still ping this name by entering ping www.bbc.co.uk. Note this line where the system converts the name we understand, www.bbc.co.uk, into the IP address the internet understands and then does the ping. Here we can see that the ping has taken 20 milliseconds, 20,000th of a second to reply. This is really good news, as it means our system somehow knows how to convert names into IP addresses. It means our Pi is connected to the internet, as we can ping the BBC, and the most important organisation in the world, the BBC, is still there. So, our ping can ping the BBC. Did we tell the Pi where the BBC was or how to get to the BBC? Where did that ping go? We can find out by tracing the route the ping took. The command to trace the route is one word, traceroute. Again, what appears on your machine when you run this command will be different as you're in a different location, or may take different routes from the one that appears here. This is a list of places visited by the ping as it travelled between our Pi and the BBC. The lines with 3 stars are unidentifiable. Here we can see line 1, the local router, and the next hop to Whitchurch Exchange, then down to Cardiff Core Link. Here is Birmingham, and this link Telehouse, a great terrorist target, the main internet node in central London. This is a little like a sat-nav that notes which junctions we take on our road journeys. So, this is terrific. We've extended the internet to connect our 4 Raspberry Pis. Job done. But where did the Pis discover the internet? How did they know what the BBC was or how to get to it? It's not magic, and this is how it's done. Every Pi built with a network port is exactly the same, apart from one thing, and that's a small number stored in its network chip. It's called a MAC address. It's different from the IP address, and we did see it presented here when we issued the ifconfig command earlier. 6 pairs of letters and numbers separated by colons, and every Pi has a different MAC address. Again, it's like your home address. It's useless unless it's unique. Pause the video now to see how this number comes about. We will split the screen to show how the school system in your home system works. This is a typical home router. It has a number of ports on the back. There is 1 WAN port and 4 LAN ports. WAN stands for Wide Area Network, i.e. the connection to the rest of the world. And LAN stands for Local Area Network, things that are local. Now this is what happened when the Pis were first turned on. They all shouted, "Help me! I'm MAC number, whatever." Nothing would have happened if there was not a box in the school or the hub at home to reply. It's a special function built just to listen for panicking Raspberry Pis, or in truth any other device that calls out for help. We will call it DHCP for the moment. Now, if your Pi was a house, DHCP would say, "Hello panicking house, calm down. You're actually in house number 73 in a street of 85 houses, and the name of the street is Long Street. You can get out of Long Street by going past the end of house number 1. This will lead you to all other lanes, streets, roads and motorways in the rest of the world. And by the way, if you need an address book, you can get it from the post office, who seem to know where everything is as they deliver letters everywhere." But your Pi is not a house. It's a computer that only understands numbers. So DHCP simply says, your address IP is. The number of houses in your street are encoded by what is known as the subnet mask. Any communication to a house outside your street needs to be sent to one particular address that can deal with it, a default gateway. And if you need to convert a name to an address, send all the requests here, known as the DNS, or the Domain Name Server. And that's it. Those 4 numbers tell any device about the whole global internet system. This is why engineers who design systems like this are better than advertising directors, bus drivers, coroners, dustmen, electricians, rodent removal, lawyers, mechanics, nomads, solicitors, taxidermists, undertakers, window cleaners, yacht masters and zoologists. Just 4 numbers supplied during the boot process provide access to the internet and explain where to get further information to operate effectively. So extending the internet turned out to be a good deal easier than may have been expected. In the process of connecting 4 Raspberry Pis to the internet, we've seen how a new device can connect to any network and issue a call for help. It uses its MAC address to be identified initially. If connected, the DHC replies that provides just 4 numbers that provide all of the information necessary for the device to participate in the global internet. The 4 titles for these numbers are the IP address, the subnet mask, the default gateway, and the domain name service or DNS address. The basic function used to check a connection is ping. We could trace a route used by ping by issuing the command traceroute. On both occasions, the very short periods of time taken to make a connection were measured and displayed in milliseconds, thousandths of seconds.